Luxman Gallery this afternoon, looking at aspects of the Boole exhibition. And in a few moments we are going to explore Mel Bochner's meditation on the theme of Pythagoras. Bochner has two of these in the gallery, one on this floor and one on the next floor. And what we're interested to look at today is to use the Project Muse entry points to learning as a way to interrogate this work of art and to really begin to see how we might open up the artwork and indeed hopefully the mathematics by using a selection of these entry points. So let the fun begin. So let's say if we were looking for a minute under narrative, and if I were to ask any one of you, now we're doing this quite spontaneously today, my class from the higher diploma, as it were, in teaching and learning in higher education, and or the postgraduate diploma I should say. So we're just gathering spontaneously around. So could I ask any of you, what is the story that you see in this work of art? And an interesting question in this case, how do the colours tell the story? So we might kind of gather closer to it and just spontaneously we'll be talking through. So anybody, what is the story that you see here?
It's about a triangle. The triangle is white and stands out.
You think that, okay, there's a triangle that stands out, great. Anything else?
Stones measured along the white line.
Sorry, Ray?
There were stones measured at distances
okay,
along
stones. Yeah. So this is now the story. That's what you. But like, what is the story behind this? As it were. So the story. It seems the story you were thinking is built around the triangle, and the story has, you know, it's set in stone, literally. Now, but are there other? Let's say when someone says to you, because we have the title behind you, when someone says Pythagoras' theorem, what do you think? What's the story for you? Any of you?
Algebra. Difficult
Theorems.
Theorems, maths. Yeah. So it could be quite a negative story in some ways for a lot of us. Now maybe not for some of us who are very interested in mathematics, but certainly for me the story was a haunting one that I felt, my God, I never, you know, I could say the theorem, the square and the hypotenuse equals the sum of the square and the other two sides. I can say it beautifully, but I didn't know what it meant or how to use it. So you see, you bring your own story as well. And I tell the story in some of the classes of one of my own teachers in the course when I was teaching in the education department. And he used the story of Pythagoras himself to begin to interest his class in, you know, in the second level school, in Pythagoras and the theorem. But they had never thought of it. The students thought Pythagoras was another complicated name. They had never associated Pythagoras with being a human being, with a life story of his own. So therefore, you could enter this. So, you know, an entry point we could look at, as it were, the narration as it is before us on the floor. But also, we're bringing several narratives. The story we see is dictated to perhaps by the stories we come with. In this case, you know, and in this case in mathematics, for some, it may have been a very challenging experience. So if we take a look at, so that's the question under the narrational question. And again it comes up, for example, does anything you see happening in this work of art remind you of your own life story? I can't but say, by the way, the possibilities of this. This is the second time I have tried this, and constantly the lawnmower. So we are doomed never to show this.
Leaf blower.
Because he's off again, and we won't be able to get the sound out of the
I
job.
will be okay. So.
We see anyway. So, does anything you see? Yes. Yeah. So we might have to come closer to this.
See it like this. When I was a teenager, I found it hard to apply this, the theorem, to daily life. And there was a friend of mine, or a guy I was doing some work with, a carpenter, and he was trying to arrange two beams so that they were square. There was a perpendicular angle. And for him, all he knew was that if he went 3, let's say, feet that way, and 4 feet that way, and if it was 5 feet across, that the beam was square. So he applied it, and he was living with it, but he didn't really know this.
The theorem.
So
Brilliant. Don't fall in the trap, it would be terrible. So let's say, how does it Is there a mathematician here? I'm all in the movies. So kind of say we're experientially, let's say, working it out. So so the square of the hypotenuse is equal to the sum of the square on the other two sides. So literally, how can we show that that is the case?
You've got your 4 stones along where you have 4 stones, and you have 3 stones there. So you square that, you have 3 by 3, and you have 4 by 4. So 4 by 4 is 16, 3 by 3 is 9,
And then you have
16 is
5.
25, and you're 5, 25.
Brilliant. So that's how. Now, if someone had explained it to me like that I could literally the square of that, I didn't even know the hypotenuse was the longest angle. Do you know what I mean? So therefore, and you see going, so that's 5 stones, and if you count back 1, 2, 3, 4, 5, that's another 5. 5 5s, 25. So that 25, 1, 2, 3, 9, and the same 16 plus 9 equals. So, all as you say then, applying that as so he knew it was 3 feet by 4 feet. Then 5 that you get the angle right. So I wonder why. So he calls this question of meditation on the theorem of Pythagoras, and he has several others, but he doesn't. Can anyone like? Why does he do it with the stone? I mean, he could have done this in a painting. Why does this work like? Or what is he doing?
Greeks had many philosophical questions, but these philosophical questions, even if today what we have of them is like the most general and like maybe irreal questions, they came from observing the world. Like for example, why does everybody in the world like some chord in the guitar, but when it makes a mistake, everybody knows that it's a mistake and that these sounds don't go well together. And they make maybe in nature there's some distance, there's some proportion between planets moving, so they observe nature. So maybe that's why they used wood here and stones, because actually, like if you are working with sciences and you want something mathematical, you can make it with something that is geometrically similar and you will express it more precisely. But maybe they are inspired by nature, and then they have like, why does the river always go the same way, and when you try to change it, it goes against that wall to go the same way.
So we're kind of in on the experiential level and saying like what's happening in it, and how. But like, why the stone? Like, why does he use stones? Do you think to do this? It's a great example in terms of, maybe the interest in nature. Is there any other? What ideas would you have about that? And you see, if we're thinking of it aesthetically, describing the lines and shapes of it, for example, and why the stone?
Can it be again like if you talk about Pythagoras' theorem, it can be quite abstract and you're trying to, but actually this is quite a visual representation. You know, it's tangible.
What I'm saying is, though, really just to push us further, if it were aesthetically, let's say, it could have been a piece on the wall, painted. So what is, let's say, the added value of having, I'm asking, aesthetically he chose to do it, so we're looking at the aesthetic entry point really, and I'm just loosely, why did he choose to do it through stones, and is there very interesting when you talk about the Greeks, is it there's an homage to that as well, that you're going back over time, that's like,
forms to draw on the sand.
okay, to draw on the sand, so like the wood, and the stones, why the stones?
We used to, the black there, in the black, we used to write things up on blackboard, equations. So here with the stone, you can take away and add to it, you can move the parts.
Okay, you could move this to X's. So the experience, we could change the stones, we could move them, yes.
Three-dimensional.
It's very tactile, isn't it? Sorry, John?
It's kind of like 3D, it's real structure.
Yes. Okay, and as you said there earlier, which is good, like in terms of, we think of the stone as one of the basics to which we return, don't we? As you say, always